Welcome back to the deep dive. Today, we're not looking at a cool new server or, a bleeding edge display.
Yeah.
We're looking at the unsung hero that keeps them alive, the power management system.
Absolutely.
Specifically, we've pulled apart the specs on the SurgeX SX-AEP-209 Axess Elite Plus. It's a high-end 1RU unit.
It is.
Our mission here is to get past just surge protection and really understand why this box is the absolute wall between mission-critical gear and, well, catastrophic failure.
It's basically a form of insurance. What we're really looking at is the true cost of downtime.
Right.
What's fascinating to me is that it all starts with a philosophy of avoidance, not sacrifice.
Okay, what do you mean by that?
The core tech is called Advanced Series Mode Surge Elimination. And it's just radically different from those cheap strips you buy at the hardware store.
The ones that, die after one good lightning storm.
Exactly. Those rely on sacrificial components. They take the hit, they absorb it, and then they're done. They fail.
So you have to replace them.
You have to replace them, and you might not even know they've failed. This system is non-sacrificial. It completely eliminates the surge energy without degrading. And crucially, it does this without ground contamination.
Okay, let's pause there. Ground contamination. For our listeners, why is that the real pain point?
Think of it like static on your data line. It introduces electrical noise where you need a perfectly clean zero reference.
So weird audio hums, video artifacts.
All of that, or even worse, data loss. System instability that is just impossible to track down. This system keeps that ground path surgically clean.
Okay, now this next feature really surprised me. It has something called inrush current elimination, or ICE.
Right.
Is that really necessary? I mean, a lot of high-end equipment already has soft start capabilities built in.
That's a fair question. But in a complex install, not every piece of gear in the rack is the same quality.
Good point.
ICE guarantees that massive initial rush of power when you flip the main switch, which is what kills capacitors and power supplies, is safely handled for everything. It's a universal layer of protection.
So it protects the weakest link in the chain.
Exactly. It ensures the longevity of everything in the rack.
Okay, so we're protected from spikes and startup stress. How does this help with the day-to-day headache of managing a remote rack? I'm thinking about that awful 3 a.m. phone call.
That's where the Axess Elite part really comes in. It's IP-enabled.
So it's on the network.
It's on the network. It connects to management platforms like SurgeX Connect or, other third-party systems. This lets you remotely power cycle outlets.
The classic turn it off and on again fix.
That's the one. But you can do it from anywhere. No need to drive to a data closet in your pajamas.
And it seems built for total awareness. I see it has 9 individually switchable outlets.
Yeah, 8 in the back, 1 up front, plus a locking power cord, which is a nice touch for security.
They even bundle in an external temperature and humidity sensor. Why put that in a power unit?
Because the health of your power components is directly tied to the environment they're in.
Heat is the enemy.
Heat and humidity. By integrating that, the system can alert you to bad conditions before they cause a failure. It's all part of the same ecosystem of stability.
So just to put some numbers on it.
We're talking a solid 16-amp load rating at 120 volts. And if you have a massive installation, it's very scalable. You can link up to 16 of these units and manage them from a single interface.
All in that standard 1RU form factor.
All in that 1RU.
And I saw a note on precision, a 2% tolerance on voltage accuracy. That seems incredibly tight.
It is, and that tight tolerance is the difference between keeping your very expensive, very sensitive equipment operating in its ideal power window versus letting the voltage drift.
Which is what a cheap solution would do.
Absolutely. Achieving real system stability and redundancy, it requires that level of obsessive detail.
So a final thought for our listeners. In an era that's completely defined by network uptime, we always focus on the hardware, the servers, the switches.
Yep, flashy stuff.
But how much of your reliability risk is actually sitting in an old sacrificial surge strip under a desk somewhere?
That's the question.
So think about this. What systems in your own network could benefit from moving from simple protection to truly intelligent, environmentally aware, controlled power management? And what's the real cost of that 3 a.m. drive?